Hey guys, and welcome back to the video. In this video, I will give you a full guide on how you properly document your Android code. And this will involve three things. On the one hand, I will show you how you can structure your code itself in a more readable way, so that if you, future self, or other developers look over it, they understand it quicker. Number two, code comments. I will show you what kind of comments you should add to your code and which ones you rather leave out. And number three, API doc comments. I will show you how you write a really good API documentation comment to your existing functions, classes, or whatever that is really descriptive and tells anyone how you can use a specific function. Just very quickly, why a good documentation is so important. On the one hand, it contributes to the maintainability of your product. So it makes things easier to change. Since if you understand a function well and you understand well what it does, then it's obviously easier to change it and adjust it based on some changed requirement. And then a good documentation allows easier collaboration in a team. Of course, the larger your apps get, the more likely it is that you're going to work on it with other developers. And to allow all developers to easily understand the code base, a good documentation is key. And last but not least, onboarding. If you are a developer new in a team, then you might know the scenario that you dive into a big code base and you have absolutely no idea where to start, where to make a certain change that is requested from you. And if you have a proper documentation, that helps immensely with that. So new developers are just onboarded faster in the team, which overall just ensures a much more productive workflow. And while there are much more types of documentation you could cover, in this video I really want to focus on the code-specific documentation. So making code more readable, adding comments, and adding doc comments. And I want to start in this little prepared project here, which you can clone from my GitHub repository down below. Here I've added a process payment function. And this is a function that is currently undocumented and it's not ideal. We want to now optimize that together, document it so that it's much more readable and much easier to understand for any developer. In this case, this function really doesn't do anything, so this doesn't process a real payment, obviously, but for the sake of documentation and learning how to properly document your code, this function does not need to have a real implementation here. In this case, we just simulate what it should do. So we have a sender and a receiver, which are both accounts. With this function, we want to send money from the sender account to the receiver account with a given amount. Then we have a transaction mode, which can be either regular or instant. So if you have a normal bank transaction, then you could have an instant transaction or just a regular one, which takes a few days. We can pass some optional nodes. We can pass a fee strategy, which is optional. So if there are some fees for that transaction, we can pass the strategy which calculates these fees. And last but not least, a retry count. So if processing that payment fails, then the retry count specifies how many attempts we want to make to retry this payment. And then the result of that payment will be contained in this transaction result class. Let's now go through this function very quickly, so you just get a rough understanding of what it does. First of all, it checks if the amount is less than 0. If so, then that is an invalid amount and we just throw an exception. Then, okay, what is happening here? If the receiver currency is not equal to the sender currency, so if we are sending money to the receiver and the receiver has a different currency than we do, then we need to calculate the conversion rate and check if the amount times that conversion rate is actually larger than the sender balance. Because if that's the case, then that means the sender does not have enough money to send to the receiver. Otherwise, if they are sending money in the same currency, we just check that for the amount. Next up, we check if the instant transaction mode is actually supported. So if we choose this instant transaction, but the receiver does not support that, we also return a failure result here. Then we check if there is a fee, otherwise we choose 0. And then we check if the fee plus the amount is greater than the sender balance. So in that case, the sender can also not afford this transaction, so we return insufficient funds as well. Then we have a remaining balance where we subtract the amount plus fee from the sender balance. Check if it's less than 500. I will get to that later in this video and want to ignore it for now. But if that's the case, we want to perform some additional verification. And if that fails, we also return that as a failure result. And then we can finally calculate the final amount and try to update the accounts with that. If that fails, we just retry it until the retry count is equal to 3. And then we return the final result here as a success. So far, so good. If you have such a function, you can see this is doing a lot, but it's all related to processing a payment. And if you dive into this code and you see this big function, you are probably like, ooh, what is that actually doing? And you need to take a really close look, like we just did, to really understand what each part of the function does. And that's not ideal, of course. And whenever you want to make code more readable and more understandable, It's not so much about adding a comment, or it's not so much about adding an API doc, but rather about making the code itself more readable. And if we take a look at this code again and take a look at what is really not immediately clear, well, if the amount is less than 0, with one exception, that's pretty clear, I would say. Then here we have a really large if statement and a nested if statement. So I would say what happens here is not immediately clear. Of course, it gets clear when you read the code, when you see, okay, if I multiply the amount with the conversion rate that's larger than the sender balance, it makes sense that I then don't have insufficient funds. But you actually need to go into this if statement and evaluate all these if statements and the conditions in your mind. That's not ideal. We want to avoid that. Readable code means in the end that we just read the code like a book, and we don't need to process a lot of logic in our brain, but rather understand right away what a piece of code does. And here in this case, it would be much more readable to take this piece of code and extract it into a function. And what we could do here is we could simply scroll down to our account class, and we can extend this with a little function, has sufficient funds, for example, which returns a boolean. Now this function takes a few arguments. On the one hand, it takes the payment amount, which we want to pay and check for. Then it takes a conversion rate, which is also double 1.0 by default. So by default, there is no conversion rate. And we could pass an optional fee, because all that plays a role when checking if an account has sufficient funds. And we can then simply take this code that we have up here and extract that into this function. So we want to return if the fee exists. So if it's not equal to null, then we take our payment amount and add the fee on top of that, multiply that with the conversion rate, and check if that's less than equal to the payment, not the payment amount, but the balance of this account. So each account has a specific balance, and we then check if we add everything together. If that's less or equal than the balance, then it means we can afford it. Else, so if there is no fee, we want to simply return the payment amount times the conversion rate less than our balance. And now we have a function where we just need to read the name in order to understand this piece of code. And that makes it much more readable. If we now scroll up and actually put our conversion rate up here, we can also take the fee from down here, cut it out and add it up here. And then we just check if our sender does not have sufficient funds for our amount, for the conversion rate, and for the fee, then we want to return this transaction result of failure. And then we can remove this code, and we can remove this here, because that also checks if the fee plus the amount is enough, but that is already covered with this function. And as you can see, we did not add any comment, we did not add any API doc, but just by extracting code into a function, this is now much clearer, since you don't need to process any more logic in your brain in order to understand what this piece of code does. So it's very obvious that this calculates the fee, that this calculates the conversion rate, and then we check if the sender does not have sufficient funds. This could almost be a sentence in the book. And if that's not the case, we obviously want to return a failure. But we don't need to go into this function anymore to see what this really evaluates to. We don't need to understand this condition in order to understand what this process payment function does. So this is always the first step when it comes to documenting your code, that you take a look at where you could extract something into a function, into a class, into a variable, and then give these functions, variables, and classes good names that directly tell the caller what they are used for. If we take a further look here, I would say this if statement is pretty clear, because you don't need to think a lot to understand this. If the transaction mode is instant and we don't support instant, then it's pretty clear what this checks. This if statement still isn't clear, but I will get to that in a moment. And here you could think about also extracting that into a function. So this one here, for example, a function get final amount for transaction or so, and then say val final amount is equal to get final amount for transaction. This would also make it clearer, but I think in this case, it's also fine like this, since the variable name already tells you what this if statement evaluates to. Okay, so that was step number 1 when it comes to documenting. And one more little readability hack is that you should always phrase your functions that return a boolean or your boolean variables in a positive way. So we don't want to call this function does not have sufficient funds and just negate the expression in the function itself, but rather always keep them positive, on the one hand to stay consistent, but also to minimize the cognitive load when reading that. Because our brain already knows, okay, this operator negates that, but we don't want to need to negate it twice if this function is actually already called, does not have sufficient funds. So I just keep it consistent and always keep these booleans positive by default. Okay, so that was step number 1 of making code documented and more readable, that we change the code itself and optimize it. Next up, we have code comments. Obviously, we all know these, /, and we can comment here. For example, if the amount is less than 0, it's invalid, for example. And this obviously now describes what this piece of code does. We just need to read the comment in order to understand it. So should you do that? These are really the worst kind of comments you could put in your project because they are absolutely obvious. The thing is, it's not your grandma which is reading that code, but rather other developers. And these other developers already know the programming language, so you don't need to explain to them what a specific if statement checks for by using a comment. So with comments, definitely don't state the obvious. Also, if you have something like I++, it would be completely unnecessary to say, okay, increase I by 1. This is something every single developer who knows Kotlin or who knows any programming language already knows. So this is just one line of code which pollutes your code base. So let's quickly get rid of that so you don't get used to this. Something I would also not recommend is to have a comment like this. Check if the sender has sufficient funds. In this case, we already optimized this, so the code speaks for itself, but sometimes it's not as clear. So let's say we did not refactor this yet, and you would have added that to what we do here in this has sufficient funds function. So we would write that here. That this is still good, because if you need a comment to explain what a specific piece of code does, then it's also not necessary, and it's a strong sign that that piece of code is not readable. In that case, you need to go back to step number 1 of making code more readable, because you typically really don't need comments that explain what a piece of code does. The only scenario where comments are really useful are comments that explain why something happens. And this could on the one hand either be due to a business requirement, so if there's a specific requirement for this app which is not clear by just reading the code why this code is structured like that, then a comment for that can be really helpful. On the other hand, you could also need this if you maybe need a specific workaround for a bug. And let's say you need to add some kind of artificial delay of 50 milliseconds to a code just in order to work around a specific bug which you couldn't fix otherwise. Then what would be absolutely necessary is to add a comment on top of this delay function which explains why there is an artificial delay. So, hey, this is a workaround for a bug, otherwise if you do this, then that can happen, so that if in future other developers see this delay and they wonder what is that delay for, they can immediately see the comment and see, oh, okay, that's a workaround, because that's really not clear by just reading delay. Otherwise, you risk that other developers might remove that delay statement, causing a bug which you might notice much later, just because you left out a comment. So let's just add a comment in this function that would make sense, and that is in the function I've teased already. This remaining balance being less than 500, here we don't really know why we have that check. In this case, this could be due to a requirement. So let's just add a comment due to, I don't know, international compliance regulations. Additional verification is needed if the sender's balance falls under 500 after a transaction. And suddenly, this piece of code gets context. And this comment is not necessary because it's unclear what this code does. It's pretty clear what the code does. We just check if the remaining balance is less than 500. But what we don't know is why we are checking that. And that now comes from a business requirement, that if the balance is less than 500, which is really just thought of here, this doesn't exist, but could be a potential requirement, which you could simply add with a comment. So any developer who will see this in future knows, okay, that is because of this specific requirement. And that was everything about comments already. What's now left out are API doc comments. And maybe in between, there's actually an additional type of documentation, which is not directly a type of documentation, but helps a lot with the documentation. And that is very often quite underestimated, because those are automated test cases. Because if you have a lot of test cases for your functions in your app, for example, for this process payment functions, and you have test cases that just verify a different combination of inputs here and outputs, then new developers can just look at the test cases to understand how a specific function works. And they can see, okay, actually, if I pass these values to this function, it should output that. If I pass these other values, it should output another value. So while we write test cases for a completely different reason, of course, this is a very, very nice side effect. So I would definitely recommend you to learn something about automated testing, especially because I just released a really, really big course about that, where you learn that in a huge production app in practice. If that sounds good to you, get the course clicking the first link below. And now let's dive into doc comments. Maybe you've seen these before. We can add these to functions, variables, classes, to pretty much anything. And we do that by having a slash followed by 2 asterisks and pressing enter. Now that comment turns green. And in the first part of this comment, we just want to describe what this function does. And this comment is now directed to the caller of this function. So this could on the one hand be if you write a library and those that use this library don't see your direct source code and therefore wouldn't see such comments here, but they would see such a doc comment which explains how the function works, what kind of things you might need to keep an eye on when using that function, and for example, what kind of exceptions it could throw. In this case, it's pretty clear by just reading the name of what it does. So we can just leave it at one sentence: processes a payment between 2 accounts. And if we now take a look at main activity and call our process payment function, and then hit Alt Q on that, then you will see this documentation. And here your doc comment will now be included. So you can see processes a new payment between 2 accounts. And this is also what someone will see when they use your library. But also, if you're not building a library, but rather just work on a big project, then this will immensely help other developers if they use a function, but they just want to see what that is actually used for, what kind of parameters you need to pass, and these kinds of things. So we are not done yet by far. There are much more things we can customize with such a doc comment. On the one hand, we can define all the parameters and explain what they do. So sender, which would be the account initiating the payment, then add param receiver, the account receiving the payment. We have param amount, the amount to be transferred in the currency of the sender. This is an information that is, by the way, not obvious from this process payment function, in which currency this amount is going to be transferred. But with a doc comment, you can explain exactly that. Then we have a param for the transaction mode, which is the mode of the transaction. And this can be either opening these brackets, transaction mode dot regular. So by having these kind of brackets here, we can also make this clickable, so we can also see directly what kind of values we can pass for this transaction mode. So this could be either the regular or the transaction mode dot instant, like this. Then another param for the nodes, optional nodes or description for the transaction. We then have a param for the fee strategy, optional strategy to calculate fees when left empty or when ignored, no fees will be applied. And last but not least, param retry count, the amount of attempts made to process this transaction or payment. And if we now take a look back at main activity and write our process payment function again, Alt Q, then we can now see a list of our parameters, which are clickable, and we see what each parameter now does in a very structured way. So that is obviously very helpful, but that's still not everything we can do with such a doc comment. What we can also do is specify, the return value. Obviously, we return a transaction result, and we can specify what this return value represents here. So this will return a transaction result representing the outcome of the transaction. And as I've mentioned, we can add throws. So which exceptions this function can throw, which is especially helpful if you have no idea and you need to catch specific exceptions, since there is no way to find that out if that function comes from a library, for example, unless you really want to dive into this function and take a look what it throws, or unless you want to try all possible inputs. So in our case, if we take a look, this function could throw an illegal argument exception if the amount is invalid. So throws an illegal argument exception if the amount is invalid. And then both that information will also be included here in the process payment function, throws illegal argument exception, and returns a transaction result, which you can also click on to see, hopefully see where that comes from. I'm not sure, probably not in this case. Does it work for this instant? Yes, in this case we see, okay, that's actually an enum entry if we click on that. One last thing I like to do is to include an example. So if you want to provide a code example how your function could be used, that's probably not necessary in this case since it's pretty obvious what needs to be passed for what. But in some more complex functions which aren't understandable by default, it might make sense to include an example what you could pass for which parameter. I will just paste an example here so you can see how this could look like. Example usage, and then with these backticks, you can specify just some Kotlin code that shows how you could use this function here. And then when calling this function, you see this example here with syntax highlighting, so you see how this function could be used. And yes, that's how you write a doc comment. You don't really need this for every single function of your code base, but rather for those that are quite complex. So again, I would say leave out those that are absolutely obvious. So I wouldn't write a doc comment for getter and setter functions, for example, or for functions which just contain a single line, which already tells you what it does. But for such rather complex functions where it might not be clear how this function could be used and what really happens behind the scenes when calling this. And definitely always include everything that is not immediately clear when using that function. So let's say you have a function that returns an index, then you could explain for the return value that the index would be -1 if an element with that index could not be found. So that's a typical use case where such a return keyword here would be a very nice use case, because it's not obvious that if an element in the list is not found, that the returned index will be -1. And such comments you can now apply to pretty much anything, so also to constructors. If we scroll down here for our account class, you could also document the constructor of this. You could document specific fields of that account class, every single function. So the possibilities with that are really limitless. So I hope you enjoyed this. As I said, if you want to learn more about documentation with test cases and how you can just write test cases that always verify that a specific piece of code still works, and you can safely refactor it without being afraid of breaking something, get the course, first link below. Other than that, thanks so much for watching. Wish you an amazing rest of your week. See you back in the next video. Bye bye.